Dear students, good morning. Today we are going to discuss about the formation of difference equation. So this topic is important for 2 marks. Okay, so maybe they will ask 2 more questions from this topic. Okay, so this is also important. But previously we discussed the solution of the difference equation by using Z transform. Okay, so that is a different topic. But now we are going to discuss how to form a difference equation from the given functions. Okay, so you just to look at that. So before discussing about this formation of the difference equation, I want to define the order of the difference equation. Okay, so first you look at that order of the difference equation. Okay, so 1 minute. Yes. So order of a difference equation. Okay. Not differential equation, difference equation. Okay, sir, are you write this difference equation? Sorry. So difference equation. Okay. So first, let me take one example. Okay, so y n plus 2 a plus 2 yn plus 1 plus yn is equal to 2 power n. Okay, so here the dependent variable is y and independent variable is n. Okay, so already you know that procedures. Okay, so first to find the order of the differential equation, you just look at this given equation and you take the highest difference which is occurring in this equation. So here highest difference is n plus 2. Okay, so that is n plus 2. Okay, and you choose the lowest difference in this equation. So here n is the lowest difference element. Okay, you take the difference between these two. So n plus 2 is the highest difference and lowest difference is n and take the difference between these two. Okay, so n plus 2 minus n. So if you take the difference, then this will gives us 2 only. So the order of this equation is 2. Okay, so here the order is 2. Okay, similarly, if you take the second one, okay, so y n plus 1 plus 10 yn. Okay, so 10yn is equal to 2 power n. Okay, and one more thing here, you have to look at only the dependent variable difference. Okay, not independent variable. Okay, so here dependent variable is y, so you have to look at only the difference in dependent variables. Okay, here dependent variable is y and the highest difference in that y is n plus 1, so that is highest difference and the lowest one is this yn. So that means n. Okay, if you take this, then you can get 1. So again, this is first order of this equation is 1. So this is first order difference equation, this is second order difference equation, and you take one more equation. Okay, so this is important one. Okay, so here y n plus 1 plus 10 yn plus 5 yn minus 1 equal to some 3 power n like that. Okay, so here what is our highest difference in this dependent variable n plus 1? Okay, minus what is lowest one difference in this dependent variable is n minus 1. In this case, not n. Okay, so the lowest difference is n minus 1. So you have to take the difference between these two. Okay, so here this becomes n plus 1 minus n plus 1. Okay, minus n plus 1 will get cancelled, so 2. So here the order of the differential equation is 2. Okay, so you this is the idea to find the order of the difference equation. Okay, so next thing is how to form a difference equation for the given function. Okay, so again I am going to take examples first, then you look at how to find the difference equation for the given function. Okay, so the first example is yn is equal to, definitely they will give the functions. Okay, so yn is equal to cos n pi by 2. Okay, so this one. Okay, so this is given function. From this function you have to find the difference equation. Okay, okay, so first thing, to find the difference equation, first to find yn plus 1. Okay, so undertake, this is equation 1. Okay, so this is given function. um, Here they will ask like this: construct a difference equation from the given function. Okay, so here and one more thing, this is not an arbitrary function. This is one specific function, cos n pi by 2. Okay, so this is some special type of function, not an arbitrary function. Okay, so if you have arbitrary function, the idea is different. The formation of the difference equation is different for arbitrary function. So this is one specific type of function. So from the specific type of function, we can find the, or we can construct the difference equation as follows. Okay, so first this is our given function, or you take this is type 1. Okay, so type 1 means they will give specific function, not an arbitrary function. Okay, so if you have the specific function, then find yn plus 1. Okay, in the place of n, you just replace n plus 1. So therefore, this function becomes cos of n plus 1 into pi by 2. Okay, so this is yn plus 1. Okay, and here if we expand this, you can get cos of pi by 2 plus n pi by 2, isn't it? Okay, if you multiply these two factors, you can get this expression. 1 into pi by 2 is pi by 2, n into pi by 2 is n pi by 2. Okay, so already you know the formula for this one. Cos of pi by 2 plus theta is equal to sine theta. Okay, and here uh, you know this sorry, and this one is first quadrant, so a s t c. Okay, so this is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. Okay, in the first quadrant, all functions, all trigonometric functions are plus. Okay, in the second quadrant, sine function is plus, all other functions are minus. Okay, similarly, in the third quadrant, tan only plus, all other functions are minus. The fourth quadrant, cos only plus, all other functions are minus. Okay, so here you just look at this. Cos of pi by 2 plus theta is, if you have this pi by 2, automatically cos will change to sine. Okay, that is the usual procedure. Okay, and here whether it is minus or plus, that thing can be defined from this relation. Okay, so you just look at how to find the signs for this function based on this quadrant. Okay, so here the given function is cos pi by 2 plus theta. Okay, and pi by 2 plus theta means, pi by 2 means up to here this is pi by 2. Okay, but pi by 2 plus theta means that will be in the second quadrant, but in the second quadrant sine only positive, but here we have cos, so therefore you have to put minus. Okay, so likewise you have to find the sign of these functions. Okay, so therefore this cos of pi by 2 plus n pi by 2 becomes minus sine n pi by 2. Okay, yn plus 1. So you take this as the second equation. Okay. Next, you find yn plus 2. Okay, a maximum you can find up to this yn plus 2 only. Okay, it won't go beyond this n plus 2 terms. Okay, so next yn plus 2. Yn plus 2 means this becomes, in the place of n we have to replace n plus 2. So therefore this becomes cos n plus 2 into pi by 2. Okay, so here cos of n pi by uh, n pi by 2 plus 2 pi by 2. So therefore you can get cos of pi plus n pi by 2. Okay, and here cos phi plus theta means cos will come. Okay, phi means there is no change. Pi by 2 means there is a change. So therefore you can get cos theta only. But again you have to use this quadrant idea. So pi plus theta means it will be in the third quadrant, because pi means it will take up to the here. So this is pi. Pi plus 2 means third quadrant. In the third quadrant, tan only positive. All other terms are, all other functions are negative. So therefore again this will be minus. So this will be minus cos n pi by 2. Okay. So now you look at this. Okay, already you know that yn is cos n pi by 2. Here we have yn plus 2 is equal to minus cos n pi by 2. So now from this third equation, now you take this as the third one, and from third we can construct the difference equation, because this is in the left hand side we have yn plus 2. In the right hand side we have minus cos n pi by 2 is yn. Okay, so now this is our difference equation. So yn plus 2 plus yn is equal to 0. So this is our difference equation. Okay. In sometimes from first two equation we can construct the difference equation. So we will discuss in the next example. Okay. Just look at the next example. Okay. Suppose the given function is yn is equal to n. That's it. This is second example. Okay. So you take this as the first equation. Next you find yn plus 1. So yn plus 1 will be is equal to n plus 1 only. Okay, because in the place of n you have to put n plus 1. Okay. So already we know that n is equal to yn. So therefore here itself we can form the difference equation. Okay, so yn plus 1 is equal to 0. So therefore this implies yn plus 1 minus yn is equal to 1. So this is our difference equation for the given function yn is equal to n. Okay, so this is the simple one. Okay, so what I want to tell here, somehow you have to eliminate this yn from the given equation. Okay, sorry, your n, that arbitrary term from this equation. Okay, so this is the type 1 model. Okay, next type 2 model. So type 2 means the given function contains arbitrary constants. Okay, so next one is type 2. Okay, so you just look at this type 2 equations. Okay, so this type is important one. For example, you take again the example. So yn is equal to a power n plus the you write b power n. Okay, so these things. So now here we have two arbitrary constants. A is one arbitrary constant, B is another arbitrary constant. Okay, so we have to eliminate these arbitrary constants an and bn from this equation. Okay, if we eliminate that an and bn, you can get the difference equation. Okay, so it just look at how to eliminate these arbitrary constants, or sometimes this equation will be of this form. Okay, so actually you take this one. Okay, So yn is equal to a into 2 power n plus b into 3 power n. Okay. So this function. Okay. No need to take this one and this. Okay. This is 2. Okay. So our aim is to eliminate these arbitrary constants, the a, b, okay, from this equation. Okay, once if we eliminate this, you can get the difference equation. Okay, but here to eliminate that a and b, we are going to use that determinant idea. Okay, you just look at how to use that determinant idea to find the difference equation. Okay, so first thing, as usual, first find yn plus 1 and to take this is equation 1. Okay, yn plus 1 means the place of n you just put n plus 1. So a 2 and n means n plus 1 plus b 3 n means n plus 1. Okay, and you rewrite this expression as this equation 1. So that means yn plus 1 is equal to if you split this 2 power n plus 1 as 2 power n plus 2 power 1, then you can get 2 times a 2 power n will come. Similarly here this is 3b 3 power n will come, isn't it? Okay, next you take this is equation 2. Next you find yn plus 2. Okay, n plus 2 means in the place of n you have to put n plus 2. So therefore a 2 power n plus 2 plus b 3 power n plus 2. Okay, so again you rewrite this equation as 4a 2 power n. Just split this 2 power n plus 2 as 2 power n into 2 power 2. So 2 power 2 is nothing but 4. Okay, similarly here 9b 3 power n. Okay, so this is our third equation. Okay, now you have to eliminate this a b or this a 2 power n and b 3 power n from the given equation. Okay, to eliminate that a 2 power n and b 3 power n, we are going to use that determinant model. Okay, so you just look at how to use that determinant to eliminate this a 2 power n and b 2 power n. Okay, so here we have to eliminate this a 2 power n and b 3 power n from the equation 1, 2 and 3. Okay, to eliminate this I'm going to use determinant. Okay, in the left hand side, okay, we have this yn plus 1 and yn plus 2. Okay, you write that left hand side expression yn, and here yn plus 1, here we have yn plus 2. Okay, next you use the coefficients of this a 2 power n and b 3 power n. From the first equation, the coefficients of a 2 power n is 1 only. Okay, and b 3 power n, the coefficients of b 3 power n is also 1. Okay, the next equation, that means in the second equation, the coefficients of a 2 power n is 2. Okay, and here the coefficients of b 3 power n is 3. Okay, the next, the third equation, the coefficients of a 2 power n is 4 and b 3 power n is 9. Okay, and take this determinant equal to 0. Now you can get the difference equation. Okay, so this is determinant only. Instead of taking the row, I am going to take a column wise determinant. So if you use that column wise determinant, then yn is equal to, sorry, yn into this 2 into 9 and 4 into 3. So 18 minus 12 is 6. Okay, minus yn plus 1 is here 9 minus 4, so 5. Okay, plus yn plus 2 is equal to into, here if you use this, then this. So 3 minus 2, so 1. Okay, so this is equal to 0. If you simplify this, you can get, actually usually we will write the highest difference in the different variable first. So therefore we y n plus 2 plus minus 5 y n plus 1 plus 6 y n is equal to 0. So this is our corresponding difference equation for the given function. Okay, so did you get my point? So this is important one. Okay, so first thing is type 1. So in the type 1 we have only specific function. Okay, but in the type 2 we have arbitrary constants. Okay, so if you have that arbitrary constant, you have to use this idea. And one more thing, if you have two arbitrary constants, you can construct second order difference equation. So this is a second order difference equation because the difference between highest derivative minus lowest one is 2. Okay, if you have three arbitrary constant, then you can get third order difference equation. That is also important. You just look at the example for the third order difference equation. Okay, fourth one. Okay, suppose the given function is yn is equal to, okay, a minus 1 power n plus b 2 power n plus c minus 2 power n. Okay, now we have three arbitrary constants. Okay, then from this we have to find the difference equation. Okay, since we have three arbitrary constants, we are going to form a third order difference equation. So you have to find up to yn plus 3. Okay, so you just look at how to form this difference equation. First find yn plus 1. Okay, so yn plus 1 means a into minus 1 power n plus 1 plus b into 2 power n plus 1 plus c into minus 2 power n plus 1. Okay, now we expand this and we take this as equation 1. Okay, next equation, n plus 1 is equal to minus a minus 1 power n plus 2b 2 power n, okay, plus minus 2 or minus 2 c minus 2 power n. Okay, next thing is yn plus 2. Okay, so yn plus 2 means you have to replace this n by n plus 2. So a into minus 1 power n plus 2 plus b into 2 power n plus 2 plus c into minus 2 power n plus 2. Okay, now yn, you take this as equation 2, and here plus 2 is equal to minus 1 into minus 1 is plus 1. So a minus 1 power n will come, and here 4b 2 power n come, and here plus 4 c minus 2 power n will come. Okay, we take this is third equation. Next, fourth one. That means here we have three arbitrary constants, so that's why we are going to find yn plus 3 also, because this will leads us third order difference equation. So that's why. Okay, so next a minus 1 power n plus 3 plus b 2 power n plus 3 plus c minus 2 power n plus 3. Okay, so here yn plus 3 is equal to minus a minus 1 power n will come. Next, plus, sorry, this is 3 only. So 3 means 8 will come. So 8b 2 power n, and here also minus 8c minus 2 power n will come. Okay, so this is fourth equation. Okay, so from these four equations, you have to eliminate this a minus 1 power n, b 2 power n, c minus 2 power n. To eliminate that, you take this determinant of this one. So yn plus 1, yn plus 2, yn plus 3. Okay, So this is determinant of 4 by 4 matrix. That is also important. Next step. Here the coefficients of this thing is 1 only. So 1, 1. Next step. From equation 2, the coefficients of this one is -1, 2, -2. -1, 2, -2. Next step. From equation 3, the coefficient is 1, 4, 4. Equation 3, the coefficient is -1, 8, -8. Take the determinant equal to 0. Okay. So as I told earlier, you take the determinant in the column wise. Okay. So this leads us yn into determinant of this. So determinant means you have to leave the corresponding column and row. So remaining terms are -1, 2, -2, 1, 4, 4, and -1, 8, -8. Okay. Next, minus yn plus 1 into leave this corresponding row and the column. Okay. Then we have the determinant of 1, 1, 1, 1, 4, 4, -1, 8, -8. You have to take the determinant for this and this. Okay. Next, plus alternatively plus and minus will come. So first one is plus, then minus, and then plus yn plus 2, and the determinant of yn plus 2 means we have to leave this with this. So 1, 1, 1, so 1, 1, 1, -1, 2, 2, -2, and here -1, 8, 8, -8. Get it done. Next, minus yn plus 3. Okay, so minus yn plus 3 means minus y plus 3 means the determinant of 1, 1, 1, -1, 2, 2, 1, 4, 4. Okay, this is equal to 0. Further, you have to find the determinant of this matrix, this matrix, this matrix, this matrix, and to simplify, you can get the difference equation. Okay, but the resultant difference equation has the degree 3. Okay, because the highest difference is n plus 3 and the lowest one is n. So the difference between n plus 3 and n is 3. So third order difference equation is obtained from this function. Okay, so that's thing. So why we are discussing the order means the suppose a function contains three arbitrary constants, then the resultant difference equation will be the order of 3. Okay, so that's why we are discussing the order of the difference equation. Okay, okay. So I stop this session here. Okay, so the next class we will discuss the solution of few difference equation which contains non-homogeneous part. Okay, so that thing is part. Okay, thank you. I stop this session here. Okay, okay. So sorry, one more problem. That one more problem is also important. So that's why just look. Yeah. So this one. Fourth one. Okay. Suppose if you have the function is like this a 2 power n plus v n times 3 power n. then can find the difference equation. Here we have two arbitrary function, so therefore we can construct a second order difference equation. Okay, so you take this is equation 1. Next yn plus 1. So yn plus 1 means a 2 power n plus 1 plus b. Again in the place of n you have to use n plus 1 and 3 power n plus 1. Okay. So if you rewrite this equation 2 times a to power n, and here you have to look at only this b 3 power n only. Okay, so therefore this becomes 3 b n plus 1 to 3 power n. Okay, you no need to worry about this n. Just look at b 3 power n. B 3 power n is, so that's it. Okay. Next yn plus 2, and this is our equation 2. Yn plus 2 means n plus 2 means 4 a to power n will come, and here 9 n plus 2 b n plus 2 to 3 power n will come. So this is our third equation. Okay. So now you eliminate a 2 power n and b 3 power n from these three equations. To eliminate that, we are going to use determinant idea. So yn plus 1, yn plus 2. Okay, and here the coefficients of a 2 power n is 1. Here also b 2 power n is n. Just look at this. We are eliminating only b 3 power n. So here the coefficient is c. Similarly here coefficient is 2. But here the coefficient is 3 into n plus 1. Okay. Next, here 4 and here 9 into n plus 2. Okay. We are eliminating only b 3 power n and a 2 power n. So that's it. So here also b 3 power n means rest of the term. That means the 9 n plus 2 is the coefficients of this one. So that's why we are writing here. So this will be equal to 0. Okay. Now you take the determinant. Okay, in the column wise. So yn into this 2 into so 18 to plus 2, okay, minus 12 into n plus 1. Okay. Next minus yn plus 1 to leave this 9 into n plus 2 minus 4n. Okay, plus yn plus 2 into leave this 3n plus 1 minus 2n. Okay, so this is equal to 0. Now you simplify these things. So yn okay, into 18 into n and 18 into 2. So 18 into n is 18n plus 36. Okay, 12n, the 12 1. So minus 12n minus 12. Okay, and the minus yn plus 1 into here 9n, 9 into 18. So 9n plus 18. Next minus 4n. Okay, next plus yn plus 2 to 3n plus 3, 3n plus 3 minus 2n. Okay, so this is equal to 0. Okay, now you simplify these things. So yn into 18n minus 12n is 6n. Okay, 36 minus 12 is 14. Okay, sorry, 24. Okay, next minus yn plus 1 to 9n. So 5n plus 18. Okay, plus yn plus 2 into 3n, 2n cancel, so n plus 3. Okay. So this is equal to 0. Okay. So here, if you want to, you write the yn plus 2 as first term, okay, and yn plus 1 second term, this one. Okay. So this is our difference equation for the given function. Okay. So this is uh, this is the formation of difference equation from the given functions. Okay. So I stop this session here. Thank you. You prepare well for the in semester examination.